This mission decides whether humans can safely return to the Moon and eventually travel to Mars. Artemis 2 is NASA's first crewed test flight in the Artemis program, designed to validate every system needed for deep space human missions. Unlike a landing mission, Artemis 2 will test the spacecraft, rocket, navigation, and communication systems with humans on board, laying the foundation for lunar landings and future Mars exploration. The launch will occur at Kennedy Space Center's Launch Complex 39B aboard the Space Launch System, the most powerful rocket ever built. SLS produces 8.8 million pounds of thrust, enough to send the Orion spacecraft and its crew beyond Earth orbit. 4 astronauts will fly on this mission: Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Cook, and Jeremy Hansen from the Canadian Space Agency. Hansen's seat on the crew reflects Canada's contribution of the Canadarm3 robotic arm to the Lunar Gateway, which will assist future lunar operations, including docking, maintenance, and cargo transfers. The crew will travel in the Orion spacecraft, which they have named Integrity. Orion is a modern evolution of Apollo capsules, offering 33% more interior space and solar-powered energy systems instead of batteries. Orion is designed to support human life for extended periods in deep space, providing advanced life support, navigation, thermal control, and communication systems. The mission lasts approximately 10 days. The first 24 hours are spent in high Earth orbit, where all life support, communications, navigation, and propulsion systems are verified. During this phase, Victor Glover will perform a proximity operations demonstration, manually flying Orion near the rocket's upper stage to practice maneuvers essential for docking with the Lunar Gateway and lunar operations. After systems checks, the European-built service module will execute the translunar injection burn, propelling Orion toward the Moon. The spacecraft will follow a free return trajectory, a figure-8 path that uses gravity from the Earth and Moon to naturally guide Orion back in case of propulsion failure. At its farthest point, the crew will travel between 4,600 and 6,400 miles beyond the Moon, breaking the human distance record set by Apollo 13. While passing behind the lunar far side, radio contact with Earth will be lost for 30 to 50 minutes. During this time, the crew will be the first humans in over 50 years to observe the lunar far side directly. This segment is essential for testing Orion's autonomous systems and astronaut procedures without Earth-based support. Artemis 2 will also test the Orion Artemis 2 optical communication system, nicknamed OPCOM. This laser-based communication system transmits data using infrared light at rates of 80 to 260 megabits per second, enabling high-definition video transmissions and rapid telemetry updates, a major improvement over traditional radio systems. OPCOM demonstrates how future deep space missions will maintain high-bandwidth contact with Earth. The launch is currently targeted for no earlier than April 2026. Delays allowed NASA engineers to address critical issues discovered after Artemis 1, including cracking and uneven shedding of Orion's Avcoat heat shield during reentry. The cracks occurred because gases trapped within the material expanded during the skip reentry maneuver. For Artemis 2, NASA will retain the existing heat shield but modify the reentry trajectory to reduce exposure to the temperature ranges that caused the previous damage. Upon returning to Earth, Orion will enter the atmosphere at Mach 32, encountering temperatures approaching 5,000 degrees Fahrenheit. A series of parachute deployments will slow the spacecraft before it splashes down in the Pacific Ocean off the coast of California. NASA and U.S. Navy recovery teams, trained extensively in the Neutral Buoyancy Laboratory and at sea, will retrieve the crew within 2 hours. This operation validates crew safety procedures for future missions. Artemis 2 is the final verification mission before Artemis 3, which will land humans on the Moon, including the first woman and the first person of color. Artemis 2 confirms that Orion, SLS, crew operations, life support systems, and communication technologies function under actual deep space conditions. Its success is a decisive step towards sustainable human exploration of the Moon and preparation for Mars missions. In addition to testing human and spacecraft systems, Artemis 2 will provide unique scientific opportunities. Observations made from behind the lunar far side will improve lunar gravitational mapping, radiation environment measurement. These data are critical for planning future lunar and Mars missions, where human survival depends on precision engineering, redundancy, and reliability. Artemis 2 is more than a test flight. It is the first chapter in a new era of human space exploration, bridging the gap between Earth orbit and a sustained human presence beyond our planet. Follow Proxima Science or stay in the Stone Age.